I'm here with Matt Hastings. Thanks for joining us for our presentation on DSCOMPROMISED, a Windows DSC attack framework. By way of quick introduction, I'm the Chief Security Architect for Tanium. We are a endpoint security and systems management software company. And I work directly with Matt, who's also a security director on my team. And both of us have backgrounds in penetration testing, incident response, and forensics, and in particular, incident response and forensics for large-scale targeted attacks. Prior to working at Tanium, we worked at Mandiant for 6 years for myself, 3 or 4.
Yeah, about 4.
Investigating targeted attacks. And so as part of that, we spent a lot of time continuously chasing the tail of attackers that often deployed novel techniques to break into environments or to persist and evade detection. And that actually led us in 2014 to do a presentation and research on investigating PowerShell attacks at Black Hat and DEF CON and a few other conferences. And the impetus when we did that research 2 years ago was working a case where an attacker used some, at the time, really novel techniques to compromise and persist in an environment with PowerShell. And we were caught in the difficult situation of having to figure out the best analytic approach for those techniques after the fact. So following that presentation and research, we kind of wanted to go a step further and see where else we could take our look at PowerShell and how it can be used and abused by attackers, and try to be a little bit more proactive about it. And so that led to this work that we're going to present to you today. So we're going to provide a quick background on DSC before we launch into the overview of our DSCOMPROMISED framework and the attack scenarios that we're going to go through. Then we're going to switch from offensive mode to defensive mode and talk about sources of evidence and investigating or detecting the toolkit that we've provided and the attack scenarios that we outline. So let's begin with that background. Just by show of hands, and don't be shy here, how many in the audience have used DSC, desired state configuration, before? I see one hand up.
One.
Yeah.
That's about right.
Yeah, that's about right. We actually did this presentation in an earlier form about 6 months ago, and I think we had 1 or 2 hands up there. Suffice it to say, a lot of people don't even know this thing exists, so let's talk about what that is. So DSC is the next-gen configuration management platform for Windows. It is fully instrumented via PowerShell. It is an intrinsically PowerShell-driven solution. But at its core, it enforces configurations using a very old standardized format, which is MOF, Managed Object Format. It has a few distinctions from the other technologies you've probably seen to manage Windows systems. For example, unlike SCCM or group policy, you need not be on an Active Directory domain to manage systems with DSC. And so part of the design consideration was to really have a next-gen technology that was agnostic of domain environments, agnostic of being on the traditional legacy corporate network to configure systems at scale. And there are a lot of similarities in DSC to Puppet and Chef. In truth, there's actually some distinctions in that DSC is not a complete solution stack as Puppet or Chef are. And so you can think of DSC as kind of the engine that's enforcing the configuration layer. In fact, Microsoft has done work to make DSC interoperable with some of those other technologies. So what can you do with DSC? As the name implies, the concept is to have a desired configuration state of a system and make sure that it remains true over time. And it does so by means of what are called resources. And these resources are basically capabilities that DSC can enforce on systems. Those resources include things like being able to download and create files, to execute processes, to run scripts, to create or manage the privileges of users, to control services, to edit the registry. And when we first looked down this list of resources when we were exploring DSC, the first thing that came to mind was that this list of capabilities is very similar to what you'd ascribe to a full-featured backdoor. Now, that isn't necessarily fair because I think the line between a full-featured backdoor and any system administration toolkit is often blurry. It's intent that really makes it different. But we also know from our past experience that the best attackers are those that leverage built-in system capabilities to do their dirty work instead of having to roll their own tools. And so this is what got us interested in seeing how this could be used in attack scenarios. So the basic workflow for how DSC works is you author a configuration, and that spits out a MOF file. And that MOF file then has to get delivered and ingested to the system that you want to configure. And DSC supports this through two modes of operation. The first is push, and the second is pull. And they work exactly as they sound. Push literally means your server has a configuration MOF file, and it's going to connect to your remote system using the WinRM, the Windows Remote Management Protocol, to send it. Pull mode means that you tell the client to retrieve the configuration from a server that's hosting it, literally a web server hosting the MOF file. And in pull mode, that can be achieved over SMB, HTTP, or HTTPS. And it's those latter two that are particularly interesting. By intent, this can work with a non-internal, non-domain joined configuration server, meaning a server on the internet can host these things. And we'll show you how we use that in our scenarios. So the system to be configured, the so-called victim, consumes the configuration and then automatically continuously monitors for drift. And if it detects drift, if it detects that the config is no longer being applied, it fixes itself. This is the core of how DSC works. To be explicitly clear, and hopefully half of you don't all leave the room at this point, we have not found zero-day vulnerabilities or really any intrinsic vulnerabilities in how DSC is designed or implemented. And what I mean by that is we have not exploited anything that's wrong per se in DSC. We haven't even detected ways to privilege escalate. As you probably are guessing, you cannot configure a system with DSC unless you have administrator equivalent credentials or access to it. But what we have done is identified ways that DSC could be abused as a covert persistence mechanism. And this is consistent with every other persistence mechanism that you see attackers use in Windows, be it services or run keys or Explorer extensions. All of those are built-in Windows mechanisms that attackers hijack to persist malware. So we thought, why not DSC as well? What we then wanted to do was simplify the process for weaponizing it, because we quickly found that DSC is not too easy to use. And then finally, to be responsible citizens and to really drive the detection and response part of this forward, we wanted to provide information on how to actually detect that this is occurring. So why would an attacker choose to use DSC? I think one reason is that it is obscure and flexible. Obscure meaning none of the security tools that Matt and I have used in our past lives, even things as comprehensive as like auto runs, identifies processes or scripts that are persistent via DSC, which means it's a huge blind spot in the security monitoring and operations of most organizations. Based on the fact that only one person in this room raised their hand for even having used DSC before, I'm going to guess that most of you, if you're working in a SOC or in an IR capacity, are not continuously monitoring for abuse of DSC. And so we'll provide some info on that, but I think that's one reason why an attacker might pursue this. The other feature that's really nice is by design, because DSC is continuously reinforcing a config state, that provides an attacker with the ability to automatically reinfect a system that is not properly cleaned up. And that's kind of cool. So we'll show you how that works in our attack scenarios in just a moment. So the limitations, as I alluded to earlier, first and foremost, it is not easy to use DSC. There isn't a ton of documentation out there because it's so new and because so few people are using it except for this very hardcore community of like PowerShell and DSC enthusiasts. It is also relatively new, and by that I mean you need PowerShell and Windows Management Framework 4.0 or later to use DSC. That is the default version in 8.1 and Server 2012 R2 and later, so it is going to be more and more prevalent, but in both of our experiences, most organizations are still running Windows 7 by and large as their most common workstation OS. You can upgrade WMF to 4.0 or 5.0 on older versions of Windows, but very few people do that. And then, as I said before, it does require admin on your victim host. Again, that's not terribly uncommon as part of an attack lifecycle for an intruder to gain that level of credentials. So again, just to be clear, this is not a vehicle for priv escalation, it's strictly a vehicle for persistence. So why did we do this in the first place? We grappled with whether this was responsible research early on because Matt and I primarily work defense. When we were consultants, even now as builders of software, we work more on detection and defense rather than offense. But I think we do also both believe that good offense breeds good defense. And we were frankly sick and tired of the forensics community always having to chase attack techniques after an attacker had already successfully deployed them in the wild. That was exactly what happened to us when we did the PowerShell research 2 years ago. We had to work a case that had an attacker that clearly knew more about offensive use of PowerShell than the forensics and IR community knew of corresponding detection and response. So we wanted to turn that on its head and actually out a potential attack technique before anyone's actually used it, or at least as far as we can tell. So we did this research. We have yet to find any evidence of anyone using this technique in the wild yet. That doesn't mean it isn't happening, but it does give us hope that maybe we can get this out there and make people aware of it so that red teams can use it effectively and so blue teams can know how to detect and respond to it. All right, and with that, I'll turn it over to Matt to discuss our DS compromised framework.
Thanks, Brian. Hey everyone, good morning. So in conjunction with this talk, we've also released, and Ryan's talked about it a little bit, this DS compromised framework. And really what it is, it's a collection of PowerShell scripts and modules that helps someone in a proactive sense use DSC to basically take advantage of some of its features. And really we decided to do this for two key reasons. The first one being that, as Ryan always mentioned, DSC is hard to set up and use. We found that there's a ton of quirks with it where if you don't set it up exactly right, you'll get an error message that doesn't indicate anything of what's related of what actually went wrong, and there's no documentation for it. So the first thing that we did is kind of take those steps that we found to be difficult and automate them through scripting, and hopefully will make the process a lot easier to actually get set up and get moving. The second part of that is refactoring some of those resources Ryan mentioned earlier. So a DSC resource is really just your ability to interact with something on a system. And so there's like a file resource, a registry resource, a process resource. So we've either refactored those, rewritten them, or combined them completely in order to build out more proactive use cases with DSC. And we'll talk about those in the coming slides. The framework itself has a set of scripts designed to set up this pull server or the C2 server. And that's the configure server PowerShell module. So that's a full-fledged module with a bunch of different functions in it that walks through the entire process of setting up the server, building out your configurations, and then ultimately infecting your victim with this configure victim script. It's all available on GitHub if anybody wants to check it out. I'll just give a quick plug. We're absolutely accepting pull requests and issues. So if anybody wants some future enhancement ideas, please submit them. I would really appreciate that. When we first set out in looking at the design of what we wanted DS compromised to be, the first thing we needed to do is decide if we wanted this to operate in a pull mode or a push mode. So Ryan mentioned the push mode is when the server itself pushes out the configs via WinRM, and the pull mode is when the clients themselves initiate a connection outbound to the server and pull them down either via SMB or HTTP or HTTPS. If you can think about traditional backdoor malware, HTTP and HTTPS communications outbound to the internet are obviously much more advantageous than having your server try and push connections or push objects inbound to an internal environment. That's likely not going to be allowed and also will raise a lot of red flags. So we opted for this pull mode approach. So each client then would initiate this, what we call, quote unquote, a beacon out to the C2 server and say, hey, do you have a configuration for me? And then go ahead and pull that configuration down. The server itself can be on the internet. In all of our testing, we had it in an AWS environment, and our local VMs were functioning as our victims. You can absolutely do it on an internal server also, but just be aware when you set it up, there's a bunch of different requirements that get installed and a few Windows services that get added. So if you think about if you're infecting an internal victim and you add a bunch of Windows services, chances are that's going to set up some red flags.
Yeah, when we did this testing, the server we set up, the C2 server, was always an AWS or Azure machine in the cloud.
And so this workflow is pretty straightforward, and we're going to walk through it. But the first step would be configuring your server, setting up some of the dependencies, and then running the configure server module. Then building out these payloads, which are just our version of wrapping these resources, and then we'll talk about those in a bit more detail. So in this case, it would be either our payload or user resource, and then configuring our victim to go out and actually pull these resources down and then infect themselves or produce change. So let's walk through our first attack scenario. So this would be, we want to infect our machine with backdoor malware, our victim. We want to ensure this malware continues to execute and remain on disk. This is pretty standard. This isn't anything that I would consider novel or different than what traditional backdoor malware already achieves. The difference here with DSC and what I really liked is, if not properly remediated, DSC will automatically reinfect the victim by redropping the file and re-executing the process automatically without notifying the user. So while a blue teamer might think that they've already effectively remediated a system, in fact they haven't. And what you'll see is that the system will go ahead and reinfect itself without notification. All right, so we're going to give a quick video demo. Since we don't believe in live demos, we pre-recorded this one. So before we get started, on your left is going to be our victim machine, and on your right is going to be the server. So the server is going to be the remote server that we've configured to host these configurations, and our victim, in this case, we're going to assume is an internal system that we're going to take advantage of.
And the payload that we're going to show you here is a simple netcat reverse shell. So on the right-hand side, we're actually going to set up the listener on the server, and on the left-hand side is where the victim's going to run the client component.
So the first thing you do is we doc source this payload file, and then we run this configured payload binary. We give it a source file, so whatever we want to produce on the victim needs to also exist on the server. And then we tell it where do we want it to be put on our victim machine and any arguments that we want. Again, this is just for netcat, so these should look pretty familiar to most people who are familiar with netcat. So the output of this is going to be a GUID, and the GUID is just a unique identifier that represents a configuration. So here on the victim, again, we're just loading in our victim configuration scripts. We're just showing you that the file doesn't exist yet, and we're showing you that it's not actually running. All right, so now we're going to go ahead and run this configure victim script, and this is very simple. It just takes an IP address to your server, and it takes a GUID that represents the object that it's going to download. As soon as this runs, you'll see a bunch of things start popping up on the screen. We'll talk about this in a bit more detail, but what it is, it's what they call the local configuration manager, downloading the configuration and then applying it.
And you can see on the lower right here, we have the listener already running.
Yep. So we have our listener running, and now it's established. So if we run something like hostname, we'll see that we're now actually executing commands on our victim. So let's clean this up. So if we exit out of the system, it's going to effectively shut down netcat running on the victim because we've exited out of this session. And now we're going to go ahead and delete the file on disk. So we mentioned it automatically reinfects itself. It does this through what they call a consistency checker, which is implemented through a scheduled task. It's created, and you can find it if you go to the scheduled task GUI. And so in this case, we're just going to go ahead and automatically re-trigger it. So we didn't want to give you guys a 15-minute demo while we waited for it to reapply. So if we want to go ahead and play it, we're now going to force the consistency checker to run. The victim notifies that it's outside of compliance, and then it reinfects itself.
So we start up our listener again and instantaneously connects back.
Right. And so one thing that I'll mention here is that when the victim notifies that it's not in compliance, there's no requirement for it to go back out to the internet to communicate with the DSC server. All the information it needs to reinfect itself is actually stored locally on the box. So all of this can be done without an internet connection. And Ryan's going to talk about some of the forensics behind that, but just be aware that there's no internet connection required here.
So just to kind of recap, we have a single PowerShell script that we run on the victim host, and all of the legwork of transferring the malware and making sure it keeps running and making sure it's on disk is then automatically done through DSC. That need not even be dropped on disk. That same PowerShell code could have been delivered to the victim via remoting and then solely execute in memory. So you could shrink the footprint of this even more if you wanted to.
Yep, absolutely.
Just clicking close in the video instead of the actual one.
All right, so now let's walk through in a bit more detail what we actually did. So the first step here, with our attacker on the top, what you have here, the remote pull server that's on the internet on your left, and our internal victim here on the right. The first thing we're going to do is install the dependencies that DSC actually needs in order to run effectively. So the first thing is just run add Windows feature DSC service. This is going to download and install a lot of the features required by DSC. It's going to install those services that I mentioned, and it's going to make sure that your IIS web service starts. So one of the requirements here is that it's going to download and install IIS, and as well as a couple other services. The next thing you need to do is install a couple of PowerShell modules themselves that are required for DSC, the DSC resource kit. And so there's a link on the GitHub page that we have that points you to this site. You just unzip a file. It's very simple to do. At this point, you're more or less up and running. And then you're just going to run this initialize server PowerShell function, which just goes through the final steps of making sure everything is implemented properly. It sets the ports for you, and it gets everything up and running. So now your pull server is ready to go. This is what it looks like. There's a compliance port and a config port function option. These are all non-required. So there's a default value of 9080 for the compliance port and a default port for 8080 for the config. But if you wanted to simulate, let's say, maybe real SSL traffic, you could do 443. So that way it's less likely to set off any alarms. So now that we've done this, now we need to build and host our payload on the DSC server itself. So this is one of the steps we showed you in the video. And the first thing we need to do is actually make sure that our malware that we want to persist on the victim first exists on our server. So we just need to copy it there. And then we're going to run this new payload function, which basically just takes that script and a couple other arguments and then builds out a payload object that we pass to build a configuration. The script ultimately generates a MOF file and a unique GUID. The MOF file is then placed in the correct location, and the GUID is just maintained for you to then go and give it to the victim. And this is what it looks like. So the new payload with the source, this is where it is on the server itself. Then you provide the destination path of where you want it to exist on your victim and any optional arguments. Then you can either pipe this or store it as an object to new configuration, and it outputs the configuration file that you need. So now we connect to our victim. We execute this configure victim script. It first ensures WinRM is enabled, which is funny because if you remember the first couple slides that Ryan went through, WinRM is only required in a push mode because it executes over WinRM and it's used for PowerShell remoting. This is all done over HTTP and HTTPS, but one of those gotchas we figured out is this actually has to be enabled for some other reason, even though it's not really used. So this is one of those gotchas. So the first thing you do is ensure WinRM is enabled, and then it just takes that GUID and the IP address of your server, and that's it. It downloads the file. It also configures this local configuration manager. And we'll go through some of the more important features of that, but just know that it sets that up. Then your victim automatically downloads and applies the configuration. So this is where we started modifying some of the built-in PowerShell DSC resources. So we mentioned that there's a file DSC resource. That's true, but one limitation that we found is that it requires that file be downloaded over SMB. It doesn't get embedded in the MOF file. So what that means is you would have the Windows system account trying to use an SMB connection, in this case out to the internet, to download a file. So you have a couple issues there. The first one is that anytime you see an SMB connection out to the internet, that's probably going to generate a red flag, right? It's not something that you would expect to see, and it's likely something that's either going to get blocked by the firewall or generate an alert. The second part is it's actually really weird to give the system account privilege to download a file, and it actually takes some additional setup. So when we saw this, we kind of thought that, that's not how we wanted to work. So we actually wrote our own custom file resource. And so what this does is it actually embeds the file contents stored in a byte array in the configuration itself. So what that means is you don't have that secondary connection out to the internet over SMB, and we'll show you what it actually looks like when it's embedded inside the MOF. So in this case, our internal victim downloads the configuration MOPs, it drops the embedded malware on disk, and it goes ahead and executes it. And now our attacker is interacting with the system via the running backdoor. So this is what that looks like. The MOF path, again, is a temporary, it's not required, so again, I wouldn't really worry about it. But again, it's really simple to get this set up. I mentioned the local configuration manager, and these are just some of the more important configuration options that we set. So allow module overwrite set to true. That basically allows you to dynamically update the configuration on the fly so that the machine will then, using the same GUID, download and update a new configuration. So if this is set to false, it won't do that. The other one that's really important is this configuration mode, apply and autocorrect. So that's the most strict configuration or compliance setting that you can set, which basically says if there's any drift from this configuration, go ahead and force it back into compliance. You can also set it to just report, so no changes are implemented on the endpoint, you're just notified about it. We also set the most aggressive compliance checks and pull frequencies. So this is going to be every 15 minutes. the configuration checker is going to run to make sure there's no drift on the victim machine, and every 30 minutes, the victim machine will check back out or beacon out to the server to make sure that there's not a new configuration for them to download. So in our scenario, we're going to assume that our InfoSec Taylor Swift detects the malware, doesn't find a persistence mechanism, which she thinks is a little weird, but it's a Friday, so she goes ahead and kills the process, deletes the file, and she goes around making great music. But 15 minutes later, that scheduled task runs where it forces consistency. The client itself notifies it's not in compliance. It tells the server about this, which we'll talk about in a future slide, and then goes ahead and sets itself back. So the internal victim then re-downloads the malware every 15 minutes. The malware is recreated on the victim and executed, and then the attacker regains access to this victim machine. It's good to note here that because we have the allow override setting here, if we start notifying, or if you notice that a lot of your malware starts dropping, it's a good indication that maybe someone detected it. That's where you can redeploy a different type of malware using the same GUID, and then you can basically go back to being hidden. And then we've won. So then, without proper remediation, which we'll talk about here shortly, you can continue to reinfect your victim without really the incident responder understanding what's really going on. So in the second scenario, we just thought, well, maybe we don't want to actually have backdoor malware running. Maybe we just want to create an unauthorized user, add that user to a group of our choice, whether that be the local administrators group or whatever we want, and then automatically force compliance back into those specific user and groups. So here's a second quick video of what that looks like. And this is going to have the same setup with our victim on the left and the server on the right. So the first thing we're going to do here is just check out the user. So we have administrator and DSC victim, and we see who's part of the local administrators group. Then on the server, we're going to go ahead and run the configure user script. So we can just give it a username and a password. You have to note the password that you give it must meet the complexity requirements of the victim. So for example, if they say must meet complexity requirements, so you have to have 3 of the 4, and you don't, it will not get created. There'll be a bunch of errors that get generated and won't work. So now we're going to run our configure victim on the victim server. So we give it the server IP address and the new GUID that gets created. So this is going to be unique upon every configuration. And then we see a bunch of messages from the LCM letting us know that it's downloading and forcing the configuration.
One thing to note, for whatever reason, the user configuration resource takes significantly longer to enforce than the payload one that we wrote, which is based on the script resource. Like, I'm not sure why, because it seems like it would be simpler, but yeah.
Who knows? So at this point, we need to now check to see, who are the users on this box, and sure enough, we see that evil user's been created. And then if we look at the user membership for groups, we see it's part of the local admins group. So we've now effectively added ourselves an administrator on this box. So what happens when we remediate? So let's go through and let's delete this evil user, and then we'll force consistency. So once we force this to run, this is not going to be surprising to anyone. It's going to recognize it not being compliant, and then it's going to re-add that user and put it back into the group.
And just as we had explained for the previous video, we're manually running the consistency checker out of sheer laziness to not wait 15 minutes. Otherwise, it would just happen on its own.
So another feature we figured out with scheduled tasks is there's an option where you can only run a scheduled task if there's power plugged in.
AC power, yeah.
AC power. So this is kind of off topic, but we had one instance where we couldn't figure out why it wasn't running. We thought we had broke DSC again, and it turned out our laptop just wasn't plugged in, so the consistency checker never ran. So if you ever run into that with scheduled tasks, just plug in your laptop and it might run. So here we go, the commands. So if we just check again.
Yep, user's back.
The evil user is going to be back, as well put in the local administrators group. So if you think about what if you only, let's say, stop the process or delete the user from the group, that still results in a non-compliant finding and will be forced back in. So it's not like you can only delete it the full way. So if you just remove the user from the group, the other group will still get forced back in. So here's what we did here. And if you notice in both of the videos, the syntax is slightly different. And that's because the videos were recorded a few months ago, and we did push some new updates to the GitHub account, slightly because I realized that we were in non-compliant PowerShell function names. So we're now fully compliant with PowerShell's verbiage that they like their functions to be in. So here we have new user, we give it our username, whatever we want it to be. The password, which again must meet the password complexity requirements of the victim. One thing to realize here is this is not a secured password. So by default, this wants to take a PS object and in a very secure manner then ship it down to the endpoint. And we broke all of that so that it can be provided as a command line argument. So don't ever use this with a password that you would expect to be secured or be used other places. We had to go through a lot of hoops to make this work, so it's not secure in any means.
Put another way, if you want to use DSC legitimately, don't use the DSCOMPROMISED framework. Use the legitimate DSC resources.
Yeah, that's probably a better idea. And again, you just give it the username, the password in a group. By default, it will put it in the administrators group, but if you want to drop it somewhere else, you can absolutely do that too. And it has the same output as the other one. So the last thing I want to talk about a little bit is the compliance server itself. So we talked about being in and out of compliance. And as a good a backdoor administrator would probably want to track is, hey, who are my victims and what's going on with my victims that I have. So like any good management framework, DSC provides that for you. So we started looking into the compliance server component of the server and noticed that there's actually a new service that tracks, hey, what's the pull server status of all of my victims? And this is what it looks like. So we wrote a PowerShell function that wraps this and outputs an object for each one of your victims. So it's included in the module. It pulls information from the compliance server. So on the 30-minute interval, when your victims check back in, they also provide some information to the server, letting them know, hey, I'm in compliance or I'm not in compliance. And then there's also some codes generated if they can download them off file. So we'll look at those exactly. So this is what gets generated. So you have a config ID. This is that GUID for the configuration. One thought about some additional enhancements is to basically take that and translate it back to what actually is in that configuration. So you can see like this machine is infected with this user or has this user or is infected with this piece of binary. But right now it just maps back to the GUID. It also gives you the last check-in time, so you can check to see like when the last time your victim actually checked back in, the last time it was in compliance. The checksum, this is just a hash check of what the config ID is. The computer, which is going to be an IP or domain name depending on how this is all set up. If it's compliant, so if the last time it checked in, if it was actually in compliance, and then the status. So when it tries to download the configuration, there's a status code that's generated. We translate that for you and then let you know what that means. So in this case, our pull operation was successful. All right, now Ryan's going to walk through some of the forensic sources of evidence.
All right, so as we said when we started the presentation this morning, we thought that the responsible way to do this was to present the attack framework and the scenarios that we thought a adversary might use if they were to deploy this technique maliciously, and then likewise provide the techniques that you could use to detect it, both on the network as well as on endpoints. And so for this half of the presentation, we're going to talk about, as a blue team, as a CERT or SOC, how would you defend or detect someone actually using DSCOMPROMISED or really any abuse of DSC as part of its PowerShell capabilities? So the first is on the network, and this is true in particular if the DSC pull is configured using HTTP. It is incredibly obvious when a client is attempting to pull a DSC configuration over the internet via, or really any destination host via HTTP. You can see there is a very distinctive URI pattern here. Either a post or a get to a file named ps.dsc.pullserver.svc, and then some arguments that specify the configuration ID that it's attempting to retrieve. So quick, easy win. If you've got web proxies or anything to monitor egress web traffic on your network, and you are not using DSC, you probably should not see this traversing your network perimeter. This means the client system in your environment is trying to get a config from some host on the internet, and that's probably a bad thing. Let's look on disk. And the reason I think looking on the endpoint is particularly valuable here is what if an attacker uses the SSL mode that DSC supports for configs, or what if they do use an internal server? Network monitoring might not be then the easiest way to detect this. Fortunately, there is a wealth of evidence left on endpoints as well, and we'll talk about each of those. The first is actually where DSC configurations are serialized to disk. And this is not specific to our DSCOMPROMISED toolkit. This is true of any DSC configuration. We were actually curious about this. We initially thought it was going to get serialized to like the WMI repository or something, like objects.data. But in fact, it's actually really simple. There's a directory in System32 called configuration, and the MOF file that is pulled down from your pull server or pushed via your push server just lives there in a file named current.mof. And when a config gets retrieved, a copy is made immediately. That's called backup.mof. And so if current ever gets corrupt, Windows will intelligently just restore from backup. There is also another MOF file that gets created called metaconfig, and we'll show you the contents of that in a moment. But that basically contains the information about where the system should go to get the current configuration in the first place. And then finally, you'll see a file referenced here called pull_run_log.txt. This was the first thing we looked at in terms of potential like log sources of evidence, but we quickly saw it wasn't terribly helpful. If you look at the bottom of the command here, or the window here, I did a type command to just echo the contents of pull_run_log.txt, and it's basically a timestamp of when a config was last retrieved. So there are better log sources that give you much more detailed information. If you happen to see that pull_run_log, don't worry, there's better sources of evidence than that. So what's in the metaconfig.mof? If you actually open up the file, I don't know, if you haven't seen MOF files before, they're actually human readable text. Metaconfig.mof contains a key value pair of the server address from which the config was pulled. And so you can see right there we've got the IP and port of our pull server, as well as the configuration ID that is represented by whatever is in current.mof. And then all of the settings that Matt alluded to that are set by the DSCOMPROMISED script and the payload for how often to update the configuration, how often to check the consistency, all of those variables are persisted in that MOF file as well. So you can get a quick glimpse at what, in this case, an attacker might have configured the payload to do in terms of how it updates itself. Note that this does not actually tell you what the payload is. We'll have to look elsewhere for that. The previously attempted DSC configurations are stored in Windows Management Framework 5 and later. So that is a very new version of WMF in PowerShell that is exclusively limited to Windows 10 by default and Server 2016. Like other versions of WMF, you can manually upgrade older OSs as well, but you shouldn't expect it to be the default on anything older than Windows 10. A nice thing, though, is that in this subdirectory called configuration status, it actually tracks previously attempted MOFs. So yet another place where if you see file write activity to these directories, that is a surefire sign someone is trying to drop or configure DSC on your victim host. This view here is going to be too small, I think, so I'm just going to read through it quickly. We basically use some tools to monitor the changes to the endpoint's state as an infection occurred. So we took a Windows 8.1 box, and then we monitored file system and process events to see what are all of the things that change on the Windows side of things when an infection is being persisted. And so we used the configure payload script to drop the executable onto the endpoint, the first demo scenario we showed you. And basically it's what you'd expect. So you see a lot of MOF files get created in the configuration directory, the metaconfig, a pull config, and then current.mof. The first time you configure DSC on an endpoint, for any reason, the scheduled task to enforce consistency will be created. So down here you can see that task being generated for the first time. And then the first time you use DSC, an event log will be created. It's an ETW tracing log called, not surprisingly, Microsoft Windows DSC operational.evtx. And that log will show you some excerpts in a moment of actually record some useful data. So that log will be generated the first time you deploy a config as well. So all telltale signs the system has been changed in this way. And then if we continue down the timeline, and again, apologies for this being too small, you'll basically see the payload MOF get dropped to the temporary location that the payload script writes to before it's ultimately ingested into the current config. And then we do some cleanup work, we delete the temporary MOF, and the system now proceeds. So the basic summary of this is file write activity in that system32/configuration directory is the telltale sign that someone is dropping DSC configs onto a host. Perhaps a more practical way that I think any environment that is doing event log monitoring could start to collect and monitor for DSC usage would be to forward certain event IDs for some of the key logs. And so if you have event forwarding configured and you're ingesting that in your SIM, you might want to look at consuming some of these events because hopefully, unless you are legitimately using DSC, these are going to be very low volume. In fact, the log probably won't even exist on most of your endpoints. So the DSC operational event log specifically throws 4 to 5 events every time a configuration is set or updated. And I highlighted a few of the EIDs here. You'll have the slides so you can get the exact numbers if they're too small in the back. But basically, there's an EID that gets thrown 4102 when the configuration is initially set on the endpoint, and it will actually tell you the user SID that ran the configure payload script in our scenario's case. You'll then get a second event that actually has the URI to the pull server, so it's very obvious. If you monitor for these 4242 events, it contains the URI of the pull server address that the attacker configured. And again, in legitimate usage, I would never expect an internet hosting server to be providing configs for an internal host. So pulling that event ID would be useful. And then 4110 is an event that gets recorded when the configuration is successful. So a couple of EIDs, really simple to monitor this. I have a few other examples here. There's one other that is interesting, 4229 actually writes there's a temporary MOF file that gets written, and the path to that file is captured here as well. So you can pick and choose which events to forward, but honestly, if you grabbed 2 or 3 of these, that would be sufficient to know suspicious DSC activity is occurring on a host. The second event log that you could centrally monitor if you used event forwarding or some other pull mechanism is the task scheduler event log. As we said, the consistency checker that DSC uses, which in our case is making sure that our payload persists on the endpoint, is like any other Windows scheduled task. And by that I mean when you first configure DSC, when in our case you first run the configure payload script, this task gets registered, and so a EID 106 event will occur and specifically say that that desired state configuration task was created. There's actually 2 tasks. One is called consistency. That's the one that runs every 15 minutes. The other is called DSC restart boot task. Just like that sounds, that is the one that makes sure a config applies upon reboot. Again, these are not specifically created by our framework. These are intrinsic to how DSC worked in WMF4. In WMF 5.0, so if you're on Windows 10 and later, what we have found is these tasks are no longer used. Microsoft changed how DSC works to actually provide a scheduler that's built into the local configuration manager, the LCM. So what that means is when a system is configured with DSC in modern versions of the platform, the consistency check is hard-coded into the LCM and automatically happens. You will not see this task created as a source of evidence. And then finally, there's PowerShell commandlets that are part of the DSC toolkits that you can use to get some of this evidence as well. So if you have mechanisms to forensically execute at scale like PowerShell commands and pull the data back to compare or search for things on your endpoints, you can run some of these commandlets to look for activity that DSC might be in use. And the first is just called Get DSC Local Configuration Manager. Just as it sounds, this gives you the state of the LCM on the system. And in this case, we can see all of the settings that Matt talked about that our scripts configure, like apply an autocorrect, the 15-minute refresh, the pull mode, the GUID that's configured are all provided by this commandlet. So perhaps an easier way to get this data than manually scraping it out of the MOF file. Instead of scraping the configuration out of the MOF file, you can also run a commandlet to get that. And this is pretty neat. So get DSC configuration gets the current DSC configuration. And so what we're showing you on screen here is the configure victim payload where we're persisting a binary. And as we said earlier, the MOF file that our framework generates is basically a dropper for the executable file that gets written and rewritten to disk. And it's basically using the script resource that DSC provides and storing the binary in a byte array. And so the long and short of it is if you ran this commandlet across your environment and compared the results, you should get blank for all your systems, or something that looks like a legitimate config. I don't expect that a byte array should ever exist in your active DSC configuration on any of your endpoints without someone tampering with them. So that's definitely a telltale sign someone was trying to hack you. And this is just a continuation of that same screenshot. I didn't want to fit the whole byte array onto one screen. You can see a few other bits of the config too, like over here are the arguments that we pass. In this case, this is the netcat reverse shell. So pretty straightforward. This is the same commandlet, but for the configure user payload, where we're persisting a user account and a group membership. And again, this looks exactly like you'd expect. The username that we're creating and persisting, and the group membership that we're assigning it to. In this case, evil user and the local administrators group. One final note, again, specific to Windows Management Framework 5, so Windows 10 or Server 2016 and later, is you can actually, another change Microsoft made is the ability to persist multiple configurations at once. And that sounds incredibly basic, but probably one of the reasons DSC wasn't terribly popular is you could only have one active config at a time. It's actually part of why we shoehorned some of these payloads into this kind of like Frankenstein thing that we constructed with the script payload. With 5.0, you can actually have multiple configs active, and so when you run get DSC configuration, you just get all of the config IDs enumerated that way. Pretty straightforward. All right, remediation. Fortunately, remediation is really, really basic. All you need to do is delete all the MOF files out of the System32 configuration directory. At the next consistency check, there will no longer be a configuration to reapply, and you're good to go. Now, of course, this will not remove any of the secondary artifacts that the malicious configuration might have dropped on the endpoint. So it's not going to delete the user account, or it's not going to delete the malware you dropped or kill the process, but it will stop the consistency check from reoccurring. And so if you removed the artifacts of the intrusion or malware and you deleted all these MOF files, you now have cleaned up the system and it should be good to go. I think there are also some PowerShell commandlets you could run to unregister and remove these, but we found that this kind of brute force method works just fine. All right, so let's wrap up and summarize. DSC is probably not going away despite its slow start in terms of enterprise adoption. I think the struggles that Matt and I had to get this working and what we saw a lot of people complain about online, I think have started to be addressed with better documentation and some of the improvements that came about in 5.0. Microsoft also open sourced the DSC resource kit in June of last year. And so they're really investing a lot in trying to make this usable. In fact, you're going to find that you probably will have to use DSC at some point if you're planning on deploying Windows Nano Server. Nano Server is this incredibly stripped down server version that not only eliminates the GUI like Windows Core, but also eliminates a lot of the other subsystems for security and performance reasons. And so the only way to actually configure and manage Nano Server is actually through DSC. So you're going to have to learn it if you want to use Nano Server. Azure has a lot of hooks into DSC for virtual machine management. And so if you have or plan to stand up a large fleet in Azure, you're going to probably need to use DSC. So I don't expect it to kind of wither and die. That being said, we still have not seen DSC attacks in the wild, as we mentioned at the beginning of the presentation. We continue to see PowerShell abuse all over the place. 2 years ago when we started our research, it was still fairly limited in the wild, and now everything from targeted APT actors to ransomware use PowerShell in their payloads. DSC, I think, has that extra bit of hurdle and complexity and that smaller victim surface just by virtue of the OS requirements. But I could totally see environments that have a large fleet of Server 2012 machines being targeted by these techniques. Server 2012, I think, is more prevalent than Windows 8.1 or later on counterpart workstations. So I think you will see this technique adopted in the future, and Matt and I would absolutely love to hear if you come across it. Even if your red teams adopt this technique, it would really be interesting to get some stories from the field, and likewise we're hoping to be able to share anything that we pick up on in the future. Matt, do you want to talk a bit about some of the roadmap items for the framework?
Yeah, definitely. So, as you noticed, we have a couple different capabilities right now. You can persist a binary in a process or create a user account and force it inside of a group. Those are some basic, proof of concept resources that we either rewrote or refactored in order to just kind of show this that actually works. The first thing that we'd like to do is just continue to add capabilities. So either rewrite resources. With the DSC resource kit now being open source, you can write custom resources. So there's really no limitation on what the framework could or could not do. And it's written very in a pluggable fashion, so it wouldn't be hard to add more of these in. So a quick example would be, rather than writing that file, what you want that binary to disk, you could then just rather inject it straight into memory, so you don't have any sort of file resident forensic artifacts. The other thing would be, especially if this gets ever picked up by any red teams or anybody that does proactive engagements, one of the last things you want to do, or one of the things that always makes you look bad at the end of it, is if you leave tools behind on a victim machine and some blue team finds them 2 months later and lets you know about it. So auto-dissolve, so the ability to just uninfect all of your victims. So basically provide an updated GUID, and all that GUID did was just remove all the MOF files so that we don't have to worry about cleanup. And then the last one is dynamically updating existing configuration. So I mentioned that ability, we set that ability in the LCM, but we don't actually have a script that helps you implement it. It's a very manual process at this point, so having that so you could just dynamically update what the configuration is would be nice. But right now, that's what we're looking at. If anybody starts using the DSCOMPROMISED framework or even has some ideas, please hit us up on Twitter or just submit a pull request or an issue through GitHub. And we'll absolutely, we'd love to take a look at it. Yep.
So just key takeaways in summary. For attackers that are PowerShell savvy, and that population continues to grow daily, DSC is an interesting avenue of attack, an interesting new way to take built-in Windows features and use them to persist compromise on an endpoints. Likewise, for red teams that are seeking to emulate what targeted threat actors do to stay covert and to evade detection, the DSCOMPROMISED framework can really help automate the creation of DSC payloads to persist binaries, to persist rogue accounts, so that your red team can spend more time on the actual intrusion and less time fiddling with DSC and all of its complexities. And then finally, for blue teams out there that are interested in incorporating this in their monitoring or hunting, the fortunate thing is that use of DSC is incredibly forensically noisy. Tons of activity on the network, tons of activity on disk. The only gotcha is if you're not looking for it, you're never going to find it. And that's true for anything when it comes to abuse of operating system features by attackers. And so hopefully some of the sources of evidence we covered are easy, quick wins for your monitoring and hunting efforts to detect signs of this malicious activity. So thanks once again. Here are our email addresses and Twitter handles. Like Matt said, we'd love to hear from you if you have any questions or in the field experiences using this or responding to attacks with DSC. We have about 7 minutes left for questions, so if there are any, we'd be happy to take them at this time. Yeah.
Two questions actually from Red's perspective. You guys plan to support proxy-aware ritual. So, host needs to reach out to proxy poll like that up internet. Are you planning to support that ritual?
So I would expect that it uses the system's native proxy config because it's the actual call out to the internet is part of the DSC. That's not something we implemented. So my expectation is if you had HTTP or HTTPS configured as the pull mechanism, it should respect the system's proxy settings.
Yeah, the other thing is if you have like a lazy proxy or something where you're not proxying every port, you could just pick a non-proxied port to go out to the internet. So if it's something where it's not doing sort of like protocol detection and you're just doing 80 out to the internet or maybe even 443, you could just put it on a non-standard port and get it out that way. The victims we ran on did have AV. So the actual process of DSC is not going to be detected by AV. What you drop by DSC could absolutely be detected by AV, and then what would happen is you'd get into a state until you updated it So for anyone that didn't hear, I apologize. The question was, what happens if the machine has AV on it? Could AV detect this type of thing? And the answer is it would not detect the functions that DSC performs where they download the configuration and apply it. But what you apply could absolutely get detected. It's not like that's going to be like bypassed by AV. So let's say you drop a piece of malware that's detected by AV. It's going to go and quarantine it, delete it, whatever it does. The system's going to know it's out of compliance. It's going to put it back there. AV's just going to do it again. And you're just going to get into that cycle until you identify it, and then you could update the configuration to something that AV doesn't detect, and then it would be persistent. But yeah, that is a potential issue if you drop something that AV could detect.
One other thing that we didn't have in the slides, just for brevity's sake, is in PowerShell 3 and later, Microsoft added a nice script block logging and module logging. So in PowerShell 3 and later, if you turn that on, you get much more detailed events in the PowerShell logs of what scripts ran and what code inside those scripts ran. And the script resource that we use in our configure payload absolutely gets logged there because it is a PowerShell script. And so we did find if you have that logging set up, your PowerShell event logs are going to throw off tons of alerts. One thing we did not test is Microsoft in PowerShell 5 has started to add malicious script detection heuristics to look for some of the common design patterns that threat actors have used. And I think one of those is to look for things like byte arrays and reflectively loaded or dropped binaries embedded in a script. I would not be surprised if the way that we're embedding that might trigger some of those flags, but we didn't test on PowerShell 10 enough or 5 enough to determine if that was the case.
So if you modified the actual MOF files themselves?
Confuse the pull server? You mean? So the checksum basically is set up such that you can't tamper with the MOF file because it breaks the checksum, and then it will basically, the victim will try to repull the config from the server at that point.
So he asked about, I think there's two pieces of that. One, could you confuse the pull server on the victim itself? So let's say you change the URL of the configured pull server, would the victim go out? The answer is probably yes. You could, since it's getting those from those MOF files themselves, and the MOF files are clear text, you could probably manipulate the address of the pull server and then manipulate the GUID, and then it would pull from a different location. So that's a good test, actually. That would be really cool to look into. And the second thing, and Ryan mentioned this, is could you confuse the actual GUID that you're grabbing? And the checksum is sort of a security feature, and I say sort of because there's also a PowerShell commandlet that generates it for you. So we do that in the framework. We run the generate checksum. So if you generated, you would have to be on the server in order to do that. You couldn't do it purely from the victim because the checksums wouldn't match. But if you were on the server, you could potentially do that, where you generated a new checksum, updated the config, and then the victim would reapply it.
So I'm guessing you're thinking of the vector where a system is legitimately configured with DSC and attackers modifying the server to now have a malicious config or changing it to point to a different,
Yeah, I think your first example of pointing it to a different place would be viable.
Yeah.
That would probably work. So, yeah, the checksum would kind of catch you. I mean,
Could you repeat the question real quick?
So the question was, I think, if you injected something into the MOF itself, could it work? I think the checksum would fail, but you could potentially regenerate it. I'm not sure exactly. We didn't test that. We didn't test the manipulation of it, but it's potential that you could then actually go in and modify that file. Again, it would require admin to get to that directory. So if you have admin on it, that's another good place that you could try and check.
There is a chicken and it's called the DSC chicken and egg problem. When you go to a victim system, you can't just drop a MOF file in that config directory and have it suddenly work. There are some registration and setup tasks that you have to do that our script automates. And so that is the one prerequisite. You can't expect to just take a pre-configured MOF, plop it in the directory, create the task, and you're good to go. It won't quite work yet. Okay, any other questions? All right, well, thanks so much for coming this morning. I hope you enjoy the rest of the conference, and please feel free to reach out to Matt and I if you have any other questions. Thank you.